In a given year, there are 8,760 hours, but across the Deccan Plateau of central and southern India, rain falls for only about 100 of them. Rather than a steady year-round drizzle, this entire annual water supply typically arrives all at once in sudden, violent cloudbursts. For civilizations settling this land, the choice is absolute: capture that brief, explosive burst of water, or watch the city collapse into the dust. Between the 6th and 12th centuries, the Chalukya dynasties held a massive empire across this semi-arid footprint. Their growth relied on an engineering doctrine of in situ harvesting, catching water exactly where it falls, the moment it falls. Historical rock inscriptions and records known as kaifiyats prove that water management was a strictly regulated state priority. Kings dictated the exact depth of canals, set the costs for construction, and provided tax exemptions for citizens who built new tanks. Structural mastery of the monsoon was the deciding factor in the empire's long-term survival and regional dominance. The geography of their 7th century capital, Badami, reveals the strategy. The city was placed directly inside a deep ravine, surrounded by massive red sandstone cliffs. The architects used these rock formations to force heavy rainwater runoff toward a central depression in the valley floor. To capture runoff, they built the 12-acre Agastya Teertha tank. Stone barriers redirected escaping water back into the basin, where levels rise a foot an hour. Excess volume was routed through streets into the fort's historic Adamnala moat. They also drilled cross-cut tunnels deep into the hillsides. Because the water table inside the hill sat higher than the plains below, gravity naturally pushed clean, filtered groundwater out through these tunnels without the need for mechanical lifting. Badami was designed to function as a city-sized funnel, an early proof of integrated urban planning and hydrology. In the agricultural zones, the empire utilized a traditional engineering system known as jarukatu to construct check dams. The outer portion of these embankments was sloped to force gushing floodwater to physically jump over the obstruction, preserving the wall's structural integrity while maintaining a pool of standing water behind it. These dams were built using precision-cut stone blocks that rely on mass and tension rather than mortar or iron. On the inside of the embankment, builders applied a mixture of mud and leaves to create a seal and prevent water seepage. Later, the Kalyana Chalukyas expanded on these principles by building ornate stepwells. These multi-tiered tanks allowed people to walk down to the water level even during severe dry seasons, ensuring access for daily needs and ritual bathing. Under rulers like King Tailapa II, the empire perfected cascading tank systems. Overflow from high-elevation tanks automatically channeled down to fill a network of reservoirs further down the valley. This infrastructure was managed by communities that divided command areas into thirds, rotating water access during the driest months. When levels dropped below the gravity outlets, farmers used the Kapali lift system, utilizing oxen to draw water out in large hide bags. From micro-level stepped wells to macro-level valley cascades, the Chalukyas built a scalable ecosystem, stabilizing food production against the volatile Deccan climate. While the Chola dynasty relied on river deltas and the Roman Empire utilized aqueducts to transport distant water, the Chalukyas had to solve the problem of capturing grain where it hit the ground. The value of this infrastructure was such that when the Chalukyan king Vikramaditya II conquered the rival Pallava capital, he prioritized the preservation of their local water monuments. Today, regions like Belgaum face severe water crises as traditional wells run dry and over-reliance on deep bore wells stresses underground aquifers. Modern hydrologists are now studying Chalukyan principles of localized rainwater harvesting and gravity-fed tanks as a template for sustainable drought management. The Chalukyas re-engineered the natural contours of the Deccan Plateau using interlocking stone, gravity, and a technical understanding of the monsoon. By treating every drop of rain as a resource to be caught and stored, they maintained a thriving empire for 6 centuries. These methods didn't disappear with the Chalukyas. In the centuries that followed, the Vijayanagara Empire would inherit this knowledge, revolutionizing it with prefabricated, mass-produced block architecture to build even larger urban reservoirs.